Hello everyone, my name is Jia Hong, metric number A186738, a student from University Kebangsaan Malaysia, UKM Bangi, Selangor, Malaysia. And I'm from Group 4, and we have Muhammad RUSHDI, DANIAL FAKHRULLAH, and Muhammad FAUZI later on to discuss about arc heating. What is arc heating in power frequency heating? And by the way, we are enrolled in the course of KKEE 4133, that is electrical power generation, utilization, and high voltage. Alright, so now we'll explore what is power frequency heating. And power frequency heating is a fundamental process in industries like steel production and welding. So now let's start with some basics. Power frequency heating refers to the heat generation using a 50 or 60 Hz AC current. That's the same frequency that powers up our homes. And it's widely used because it's efficient and compatible with standard power grids. There are three types of power frequency heating. The first type, resistive heating, also known as joule heating. We have seen this in electric stoves, where the current passes through a resistive material and releasing heat as P equal to I squared R. It is simple, however, there are some limitations as this joule heating needs to lower temperatures. So this is ideal for us to in our cooking and heating up our cooking utensils to boil some soups. Next will be induction heating. Induction heating is used in cooktops and metal hardening, where it creates heat using eddy currents that induce in conductive materials. Therefore, no direct contact is needed in induction heating. Lastly, the arc heating, which is our main focus. So our focus today is arc heating, where an electric arc reaches thousands of degrees Celsius, and this is a star player in welding and steel making. Or why it matters? You need to know that arc heating is critical for modern industry. For example, over 70% of steel in the US is made in electric arc furnaces, where they recycling scrap metal efficiently. And without it, we are now still relying on slower and dirtier blast furnaces. Now, imagine a bolt of lightning trapped between two electrodes that eventually an electric arc. But how does this chaotic spark turn into a controlled heat source? Now let's begin. Arc heating is the process of generating extreme heat up to 20,000 degrees Celsius by passing current through an ionized gas or plasma, call it. This creates a sustained discharge called an electric arc. But how arcs are formed? Arcs are formed in three steps. Step 1, the breakdown stage. When high voltage is applied, the electric field rips the electrons off the gas atoms and creating a conductive path for ions and electrons. Step 2 is the sustained discharge phase. Once the arc starts, current flows freely through this ionized gas, releasing massive energy as heat and light. The final step is a high temperature plasma. So the arc's cause reaches 3,000 to 20,000 degrees Celsius maximum, and that is hotter than the sun's surface. And this temperature is enough to melt metals instantly in welding or furnaces.
Welcome and hi everyone. My name is Daniel from SUPERI A186861. Today I will present about the physics of R18. Okay, let's begin by understanding how R18 works. First, when we apply a high voltage across a gap, free electrons accelerate in electric field. As they move, they collide with gas atoms, ionizing them. This process is known as the Townsend discharge. As molecules become ionized, they can fill with plasma, which is a highly conductive ionized gas. Plasma is what allows the arc to sustain itself and produce instant heat, often exceeding 2000 degrees. For the mathematically model, the heat generated is given by the simple power equation. P equal to V R times I R. V is the up voltage and I is the current. The up voltage vary depending on the gap length, gas type, and arc current. Finally, the voltage current characteristic of an arc. As shown in the graph, the voltage drop as the current increase. This is a negative resistance behavior unique to arcs. This property is critical in how we control our gas system. Okay, so let's go to the next, which is the type of R18 system. R18 is used in a wide range of systems depending on the application. First, we have carbon R18, one of the earliest art technologies. It used carbon electrodes, but is rarely used today due to the efficiency and safety concerns. Next, the electric arc furnace, or EAF, is widely used in modern steel production. It makes scrap metal using arc heat and accounts for around 70% of today's steel production, making a critical part of the recycling industry. Then, in the field of fabrication and repair, arc welding systems are used. These include SMAW, TIG, and MIG, all of which use electric arc to join metals. Finally, circuit breaker arcs occur in power systems. These arcs are safely extinguished using techniques like SFC, gas insulation, or magnetic blowout to prevent equipment damage during switching. Okay, we move to the next slide, which is electric arc furnace EAF case study. Let's now look at the electric arc furnace in detail, which is the process types. The process begins with the charging, where scrap metal is loaded into the furnace. And the second is melting. Melting is occur as graphite electrode generate arc that can heat metal up to 1600 degrees or more. And next is refined, where impurities and slag are removed. This step helps ensure the final product meets quality standards. And lastly, tapping. Tapping is done to pull out the molten steel into molds or ladles. The EAF has several advantages. First, recycle scrap metals and consume less energy per unit of steel. And the second one is it's faster than traditional blast furnaces. That make it both cost effective and environmentally sustainable. So, this case highlights how R18 is not just a lab concept, but an industrial backbone for efficient metal processing.
Now, let's take a look at some of the key advantage and challenge of arc heating, which is a type of power frequency heating. So, starting with the advantages, arc heating offers extremely high temperature, which is crucial for application like metal melting in an electrical arc furnace. So, another benefit is a rapid heating. The arc can deliver a tremendous amount of heat almost instantly, which is significantly reduce the processing time. Precision control is also possible, especially with a modern system that allow regulation of the arc and current, enabling targeted heating. So lastly, arc heating system can be made portable, which making them useful in a field application such as repair work or emergency metal cutting. But however, arc heating comes with its own set of challenges. So one of major issue is high energy consumption, which is maintaining an electric arc require a constant and considerable supply of electricity. So this lead to electrode wear as the electrode degrade over time due to the intense heat and current. Another concern also is a harmful emission, especially in industrial settings where metal vapor and gases are released. And finally, the system can produce noise and flickers, which may affect both workers' comfort and electrical stability in neighbor system. So, understanding these pros and cons is a vital when choosing the arc heating for industrial or specialized application. Next, let's discuss the safety and environmental impact of art heating, which is a crucial consideration, especially in the industrial environment. So there are several hazards associated with art heating, which is UV and IR radiation from the arc can cause an arc eye or welder flash, which is a painful condition resulting from unprotected exposure. So the process also generates toxic fumes such as ozone or metallic vapors, which expose serious respiratory risk if inhaled. Additionally, there is always an electric shock risk due to the high current involved. So, to mitigate this risk, several safety measures must be implemented. So, first, personal protective equipment or PPE is essential. So, so that this include the helmet with proper eye protection, insulated glove, and well ventilated workspace. Next is emission control system, like scrubbers or the filter in arc furnace, which is help reduce harmful outputs. And finally, following the regulations set by the organization like OSHA or IEEE is vital. So this standard provide a guideline on equipment setups, safety protocol, and exposure limit, helping create a safer working environment. So by addressing this hazard through proactive mitigation strategies, hard eating can be employed effectively without compromising the worker safety or environmental standards.
Okay, next is comparison with other two methods. So now we compare arc heating with induction heating and also laser heating. If we take a look on temperature range, arc heating can up to 20,000 degrees Celsius, which is more than induction and also laser heating. Next, speed and also energy efficient. If we look, the arc heating is in the middle between the induction and also laser heating. And the last one is cost, which is the what we call the crucial and also the important feature that engineer will focus on. So arc heating is the cheapest method we compare between induction and also laser heating. Alright, after we know all the definition, mechanism, the advantages, the challenges, and also the comparison, we also seek for the future innovation, for the more sustainable method and also more effective method. So the first one is smart arc welding. We use AI-powered vision systems and infrared cameras to monitor welding quality in real time. The AI detects defects like porosity, spatter, and lack of fusion and automatically adjusts welding parameters on the fly. Second is green steel making. Replace traditional carbon-based agents with hydrogen in electric arc furnaces. This produce water vapor instead of carbon dioxide, making steel production carbon-free and also fully sustainable. The third one is supercritical arcs. We use ultra-high temperature arcs above 5,000 degrees Celsius to break down complex waste into synthetic gas and inert slag through plasma gasification. This allows safe, clean disposal of hazardous and industrial waste. And the last but not least, nanomaterial synthesis. We use arc discharge between graphite electrodes in a controlled gas environment to produce high quality graphene, flakes or nanotubes. This method is scalable, energy efficient, and ideal for advanced material research. So, the conclusion is arc heating is the key to modern industry, which is generate extremely high temperature above 5,000 degrees Celsius for industrial processes. Where is it used? For example is steel making, welding, and power systems. Why does it matter? Delivers fast, powerful heat but requires strict safety protocols. For future direction is automation, AI and robotic for smart welding and steel production. Sustainability, hydrogen-powered furnaces, and waste-to-energy plasma systems. Powerful, precise, and going green. Arc heating drive industry forward.